manners don't like me, they try and bad mind me when Kano comes to town. All I say is mine's right and they lose the limelight when Kano comes around. Some tracks screw me or even sue me, but it don't work cause the crowd don't boo me. You ain't a true G, I'm too deep, how can Kano stay on the ground? I ain't like most that.
So the homework this week was on integration, and the first question tells you you've got 9x plus 12x to the power of 5 over 2 over root x. And you want to write that in the form 9x to the p plus 12x to the power of q. So you need to think a little bit about how fractions are actually added together, and you'll realise that that is equal to 9x over root x plus 12x to the 5 over 2 over root x. Because when the denominator is the same, we can write them over the same denominator. We now need to write them into the form ax to the n, because right now we've got a mixture. So 9x over root x is x to the half, plus 12x to the 5 over 2 over x to the half. So we need to use our rules of indices to simplify that. So when we're dividing, we'll take it away. So we've got 9x to the power of a half. We're going to add that to 12x to the power of 4 over 2, which I'm just going to write 2 instead. And now we've written it in that form, we want to say what p and q are. So p is equal to a half and q is equal to 2. Given that the gradient function dy by dx is equal to what we've started with, and that y equals 92 when x equals 1, we need to find y in terms of x and simplify the coefficient of each term. So I'm going to use this new version of what I have just created, 9x to the power of a half plus 12x to the power of 2. We want to integrate to be able to find y in terms of x. So integrating that, we add 1 to the power and then divide by the power. So the new power would be 3 over 2. Dividing by that gives us 6x to the power of 3 over 2. We're going to add 1 to the power there gives us 3, divide by the power, plus 4x to the power of 3. And because we're integrating indefinitely, we need to add on a constant of integration. We need to plus c. Now the next part of the question, it tells us that y is equal to 92 when x equals 1. So that's more information we've been given. So remember, this thing is equal to y. So we can substitute this information in, so that 92 is equal to 6 lots of 1 to the power of 3 over 2, plus 4 lots of 1 to the power 3, plus c. And if we work all that out, we will find out what c actually is. So that tells us that c is equal to 82, if you work that out and solve it. So we've not finished the question yet, because we need to substitute that back into the original, where y is equal to 6x to the power of 3 over 2 plus 4x cubed plus 82. And that would be 7 marks for that question.
Try and bad mind me when Kano comes to town. All I say is mine's right and they lose the limelight when Kano comes around. Some tracks screw me or even sue me, but it don't work cause the crowd don't.
For the second question, you're given a curve that looks like that, and the equation of it is y equals x plus 1 and x minus 5. So the curve crosses the x-axis at the points A and B. So for part A, you need to write down the x-coordinates of A and B. Handily, it's already been given in a factorised form, so it should be quite straightforward that that's x equals minus 1 and x equals 5. You're just solving your quadratic. The second part of the question, it wants you to find the area of the region shaded. So we need to use integration as it says in the question. So by finding where it crosses the axis, we've found our limits, -1 to 5, of the function which is x plus 1, x minus 5 dx, as we're doing it with respect to x. We can't integrate that as it is, we need to rearrange it so that it's in the form ax to the n. When you multiply that out, you get x squared minus 4x minus 5. So that's what we're integrating now. The integrated version of that, add 1 to the power, divide by the new power, you get 1/3 x cubed minus 2x squared minus 5x. You don't need plus c because it is a definite integral. The limits we now write on the right hand side of our square brackets, -1 to 5. So we need to evaluate at 5 and take away it evaluated at -1. So 1/3 of 5 cubed minus 2 lots of 5 squared minus 5 lots of 5. Take away 1/3 of -1 cubed minus 2 lots of -1 squared minus 5 lots of -1. That comes out as -33 1/3 minus 2 2/3, which is equal to -36. So we've got a negative answer for our area, which we should have expected, seeing as though our region is below the curve. But we don't want to give our final answer as a negative because it doesn't really mean anything to have a negative area. So we say that the area is equal to the positive version of that, which is 36. There we go, we've got another 7 marks.
They try and bad mind me when Kano comes to town. All I say is mine's right and they lose the limelight when Kano comes around. Some try to screw me or even see me, but
Question 3 is a little bit more involved then, as you have a curve on there where part of it is above the x-axis and part of it is below. So we need to work out where it's above and where it's below, as in what's the x-coordinate when it crosses. So we can find the x-coordinate by solving the function. It's already given factorised. If it wasn't, you'd need to factorise it yourself. Y equals x, x minus 1, x minus 5. So that tells us that it crosses the axis when x equals 0, x equals 1, and x equals 5. So I'd already marked that on there. X equals 0, x equals 1, and x equals 5 is where it crosses. What we want to find is the finite region shown shaded and the area of that. So the total area of the finite region, which is shaded. So between x equals 0 and x equals 2. If you look at your curve, we've got x equals 2 there, we've got x equals 1. So we want to find this area by integrating between 0 and 1, and then find this area by integrating between 1 and 2. So I'll start by doing the integral from 0 to 1 of x, x minus 1 and x minus 5 with respect to x. We can't integrate in that form, we need to convert it into ax to the m by expanding those brackets. You end up with the integral between 0 and 1 of x cubed minus 6x squared plus 5x. The integrated version of that, of course, you add 1 to the power, divide by the new power. I end up with a quarter x to the power of 4 minus 2x cubed plus 5 over 2 x squared. I'm doing that between 0 and 1. Thus, we evaluate at 1, then we take away the function evaluated at 0. So this thing evaluated at 1, which is 1 quarter of 1 to the power of 4 minus 2 lots of 1 cubed plus 5 over 2 lots of 1 squared. We're taking away 0 because it's all variables in there, so when we chuck 0 in, we're going to get 0. It's not worth wasting time putting it all in. That will give you 0.75. So the area of that part above the curve is 0.75. So So we need to deal with the bit below the curve, which is between 1 and 2. So we're integrating the same function, which we have worked out what it is there. X cubed minus 6x squared plus 5x. We've already integrated that, so don't bother doing it again. Where we've got 1/4 x to the power of 4 minus 2x cubed plus 5 over 2x squared between 1 and 2. So that means 1/4 of 2 to the power of 4 minus 2 lots of 2 cubed plus 5 over 2 squared. And we're going to take from that, we've already evaluated it at 1, so we don't need to do that again either. I'm going to take away 0.75. Okay, so that's given us, or that will give us, minus 2.75. You can put that into your calculator to check that you get minus 2.75. So we now know that the area below the curve is minus 2.75, but of course it's an area, so we're going to do the positive version, which is equal to 2.75. So if we then got the area below the curve is 2.75, we've got the area above the curve is 0.75, add those two together, 2.75 plus 0.75 is equal to 3.5. So that is the area of the region which is shaded for that question, and that question is worth 9 marks.